My name is Christina Quintero, and this is my video lab report for Lab 4, Spring and Mass Lab. The point of this lab is to quantify the motion of a mass attached to a spring by using tracker using a video that was provided. Then, using Newton's second law and the energy principle, the motion was predicted using VPython. Then, a comparison was made between the predicted and observed motion. The motion of the mass was similar in the x and y directions. The predicted motion mimicked that analyzed in tracker, and the system satisfied the energy principle. The principles used in this lab are Newton's second law and the energy principle. The momentum principle helps predict the spring's new velocity, which in turn can help predict the spring's position. The energy principle describes the total energy in the system, which in this case is equal to the total kinetic energy, spring potential energy, and gravitational potential energy. In tracker, I used the length of the spring at rest for reference, which was 7 meters. I placed the origin at the top of the spring. After tracking the motion in each frame, I took the x and y components of the motion and transferred them into a CSV file. For the initial condition of the code, the mass of the object was given and was 0.402 kilograms, and its initial position was found using tracker and was negative 0.106, negative 0.6470. The second line of code uses the positions extracted that we put in the CSV file so that the code can read it and make a model. Next, the following equations were used to find Ks, the stretch, and the initial length of the spring. Using the recorded data, Ks came out to be 7.094, the stretch was 0.555, and the initial length was 0.1446 meters. Please pause if you would like to look in more detail. The values for Ks and L0 were then inserted into the code shown on this slide. The energies in the system are the kinetic energy, gravitational potential energy, and the spring potential energy. These energies are calculated by the following equations listed on the slide. These equations were then written in code, as you can see color-coded on the slide. This section of code defines the different forces in the system. The force of gravity and the spring force are defined with F net being the two forces added together. We then insert Newton's second law to update velocity and then the position update equation. When we run the code, it looks like this. The red ball is the data from tracker, while the blue is the computational model. The black arrow is the force of gravity, while the blue is the tension force. The graph shows the position in the y of the two models. They are relatively close, which means my model is good at predicting the motion. Error could have been due to drag in the real model and the rounding of numbers. Here is a graph of all of the energies in the system. The blue is the change in kinetic energy, the red is the spring potential energy, and the green is the change in gravitational potential energy. The yellow is the sum of the total energies in the system, which is 0. For part 1 of the what does it mean question, the work done by the surroundings is equal to the change in energy. Because the mass, spring, and earth are included as part of the system, then the work should be 0. There is no outside work done on the system, so delta E equals W, which equals 0, as seen in the graph. For part 2 of the what does it mean question, the period of oscillation for x is 2.35 seconds, and for y it is 1.496 seconds. The periods differ because the path of the ball is elliptically shaped and slanted downwards. This shows it takes longer to travel one cycle in the x direction than in the y. Thank you for watching!